Well, hello everybody. So we are going to get started with our Algebra 2 semester exam review. We're going to be covering all things Unit 1. This semester exam will take place Wednesday, December 8th. You guys have heard me say this for the last couple of weeks now. So again, your exam will be Wednesday, December 8th. There will be two parts to the exam, the calculator and non-calculator portion. So I'm going to really be focusing this year on non-calculator work just to make sure that we have a solid foundation of what we need to be able to do to be successful on this exam, which I know you guys will do. So let's go ahead and get started on all things Unit 1. So piecewise functions, we've discussed piecewise functions in the past. So this is when we have two or more functions. Okay, piecewise functions, two or more functions. So what's happening here is we're given these equations, and you'll recall like it's one equation, two equations, three equations, right? Here's 1, 2, and 3. And what distinguishes these equations is the domain. And the domain you see here is after that if. This is discussing the domain of these. So like on the first equation, it's saying 2x if x is less than or equal to -2. So it's like, well, which equation is that? Well, we know 2x is going to have a positive slope, right? So it can only be this one here that I'll circle in red. You're really not going to be tested so much on graphing, but really understanding what the domain is happening here. And so let me go ahead and erase this here. And more importantly, I want to focus on what is happening domain-wise. So we see here that we're going forever to the left, which would be -infinity, right? And then here at -2, we have this little jump happening. We have a solid, and then we have an open circle. But at -2, this does exist. And we know it exists because we see it here as also less than or equal to. And then it's all numbers through here. Everything exists. And then right here at 4, we have another jump. We're going from an open circle, which it doesn't exist, to a solid circle, which it does. So that also existed. And then forever in the right, we're going to infinity. So we could break this down into each individual parts, and it gives us the domain. We could say x is less than -2. It's from -2 to 4, not inclusive, and then from 4 to infinity, inclusive, right? But we see here that all of our jumps happen, okay? In other words, there is some type of point that does exist for every value of x. So, and that's the case, we'd say we're going from -infinity to infinity, parentheses. Well, what about our range? How far down does our graph go? Well, we're going down here forever to -infinity, and we go up, 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 and here it stops at this spot here where I'm putting this little blue arrow, but then it continues, and the highest it goes is right up here when y is equal to 1. But we have an open circle. Open. So this being the case, the lowest the graph goes is -infinity. And the highest it goes is 1 parentheses. Why are we using a parentheses? You'll recall we use parentheses when we have open circles or we are approaching a point, but we never actually get there. Had that 1 been a solid point, well, then we'd use a bracket. Okay, so I want you guys to evaluate this one here for the domain and the range. I will be circulating the room during class while y'all are working on this. So please make sure that you ask for any help if you have any issues, and I will be giving answer keys at the end of the week. Let's go ahead and move on. So let's talk about inverse relations. And so inverse relations, we discussed this during Unit 1, and then we talked about this again most recently during Unit 5. Okay? And for an inverse relation, the inverse relation R can be written as R to the power of negative 1. Okay, to find the inverse of a relation, we switch x and y, and then solve for y. Okay, in order for something to be considered one-to-one, the relation and its inverse are functions. And what's a function? You remember only, I forget only, we're not going to say only, we'll say, to make it even easier on all this here, we'll say for a function, x's cannot repeat. So if we look at example number 1 here, and I'm going to label points x, y, x, y, x, y, x, y. For my r inverse, remember we switch x and y, so this 1, negative 2 becomes negative 2, comma 1. 2, 4 would become 4, 2. 3, negative 1 would be negative 1, 3. And 4, negative 2 would be negative 2, 4. Is r a function? Well, I'm going to look at my x's. I have 1, 2, 3, and 4. Well, 1, 2, 3, and 4. None of those values repeated, so r is, yes, it is a function. What about r to the negative 1, or the inverse of r? I'm going to look at my x values here, my new ones. Negative 2, 4, negative 1, negative 2. Because these repeat, this is the big fat no. Is r one-to-one? Well, the relation is a function, but the inverse is not. So because this one is not, it is a no. So now I'd like for you guys to do the same evaluation for number 2. Again, we've done this in the past several times, so I'm not too worried about you guys doing this one. But again, if you have any questions, please let me know. All right, so verifying inverses, we did do this way back in Unit 1. It says f and g are inverses if and only f, and this would be if the composition of f of g of x is equal to x, and g of f of x is equal to x as well. In other words, once you solve for the inverse, if you put one equation inside the other, and you get the value of x, well then they were inverses of each other. So let's do this. Let's go ahead and solve for the inverse of this one here. So we're going to say y equals 6x minus 15. You'll recall, to get just a quick inverse, we're just going to switch our x and y. We'll say x equals 6y minus 15. I want to solve for y, so we'll add 15 to both sides. We'll say x plus 15 equals 6y. And then I want to isolate y, so I'm going to divide both sides by 6. And let's kind of clean this up a little bit. Instead of saying y, I'm going to say g of x being the inverse. I'll put a little arrow here. This is my inverse. And we'll say this is x plus 15 over 6. To just do a quick check, if this is true, when I plug in my original equation or the inverse into the opposite one, we should just get x. So if I do that, and we'll do that here, let's do f of g of x. In other words, I'm going to take my equation for x, which is 6x minus 15. And I'm going to put g of x everywhere I have x. So what's going to happen here is I have 6 times x, but now x is all this of g of x, plus 15 over 6, and all of that minus 15. And we can start cleaning this up a little bit. If I was to distribute the 6, well, we know that the numerator and the denominator would simplify out. So f of g of x would be equal to x plus 15 minus 15. And I realized here on the problem right here that 5 should have been a 15. We combine like terms. These would simplify out. F of g of x is equal to x. And this is a good check. That means that the equation itself, or the function itself, and its inverse were true. And when we composed one inside the other, we were just left with x. So I'd like for you guys to prove this here on this question. Solve for g of x, which is going to be the inverse. And then just don't be satisfied with that. From there, you want to check, is that inverse true? You're going to compose either g into f or f into g. At the end, you should get just x by itself. If you do, you did it absolutely correct. Again, if you have any questions, let me know. Yeah, let's go ahead and move on. So let's graph this system of inequalities and identify the shaded region. You are actually going to have graphing questions on your exam, from my understanding, without the use of a calculator. So you want to be able to do some quick graphing here. So let's do some quick tips and tricks here. For this first equation, I've got y is less than or equal to negative 2x, negative 2 over 3x minus 1. So let's first identify our b is negative 1. So I'm going to come down to negative 1, I'm going to put a point. My slope in this case is negative 2 over 3. So I'm going to go down to 1, 2 over 3, 1, 2, 3. And this is what I would use to draw my line. Now I'm going to use a solid line because, okay, oops, and that was not very straight at all. Let's go ahead and clean that up a little bit. I'm going to use a solid line because it's also equal to. Okay, if it wasn't equal to, we would use a dashed line. So let's go ahead and draw this to the best of our ability. And I'm going to want to highlight and shade everything. Now the question says here, y is less than, so it's going to be everything below. Okay, so we're going to go ahead and shade everything below. Okay, please do a better job of shading than I am. I'm just quickly highlighting everything we see below. Okay, as far as what the question is going to ask, I don't know if it's going to be like, I'll find a point or a shaded region or match the graph, but you want to be able to do this. Okay, so this is the first one. Let's go ahead and change colors. And let's do our next graph. We'll do purple here. For the next one, we're going to say my b is negative 8. So I'm going to go down to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's negative 8. And my slope is 1/2. That means I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And we're going to also use a solid line because it is greater than or equal to. So now this shades everything above. Okay, so we can, I'm going to just do a quick shade here. You guys get the point. And you're already starting to see like where that overlapping is. We already know that that's going to be super important. So I'm going to go ahead and concentrate on that overlap there. But we're not done quite yet. Okay, as we still have the last equation when it says y is greater than 4. I'm sorry, x is greater than 4. That's important. If I go to where x is 4, 1, 2, 3, 4, well, that's going to be everything here. Now my line, as I'm doing it solid here, should actually not be solid. This is x is greater than 4. So what I'm going to go ahead and do is I'm going to go ahead and, oops, and it deleted everything. I apologize for that. We're going to go ahead and fix that. We'll put our dash lines in here, not that big of a deal. And we're going to shade in everything this way here. And then we need to shade in also our purple, right? And so what's interesting is we're looking for the double shaded, right? And we see all of that. And it's actually not double shaded for this one. We're actually going to be discussing everything that's triple shaded. And that triple shaded area, I'm going to go ahead and do that in yellow, would be just right here. Okay. Because everything was either single, double shaded, or not shaded at all. But we do have this one triple shaded area. It's just that tiny little triangular spot there. Okay, I know this is kind of a lot. Please, you can actually check yourself with a calculator, but I want to make sure that you're able to do this without the calculator. So I want you all to be able to do the same thing here with this equation. I'm sorry, with this system. So you're gonna have two equations, and you're just looking to see which point falls within that shaded region. Be very careful. You'll see that there on that first equation, you're going to have to rewrite this in y-intercept form. So you're going to want to move that 5x over, maybe divide by 2x, hint, hint, okay? Graph that first equation, or I'm sorry, inequality, graph the second inequality, and then determine which one of those 4 points falls within that shaded region. This is good practice, and it aligns with the skills that we just did. Okay, again, if you need any help, let me know. And then this one here, perform the indicated operation. It says g of t is equal to 4t minus 5. H of t is equal to t minus 3, all that squared. Find g of h of negative 2. Okay, so what are we doing here? You'll see, and I'm sorry, I use that term of. It's actually not of. This is the operation here of multiplication. So we are multiplying. Okay, so what's nice about this is there's 2 ways of doing this. We can actually take the equations, we can multiply them together, which is going to be a lot of work. We'd actually have the box method and box method again, or we can find what these values are by one at a time. So if I take this g of t, which is 4t minus 5, but I know that I'm going to substitute negative 2 in there to have g of negative 2 equals 4. Everywhere I have a t, I'm going to put in a negative 2 minus 5. So g of negative 2 is equal to 4 times negative 2 is negative 8 minus 5. So g of negative 2 is equal to negative 13. My other equation is h of t, which is t minus 3 squared. When I substitute negative 2 in, I want to make sure that we're using our parentheses at all costs, right? Minus 3 squared. So h of negative 2 is equal to, well, negative 2 minus 3 is negative 5 squared. And h of negative 2, and this is where you need to be careful, it's negative 5 squared. So negative 5 times negative 5 is a positive 25. Okay? So we have this positive 25, and then we're going to want to be able to solve for our final value. Now that value, okay, it says g times h. So let's change colors here. G times h. Well, what is g? We solved was negative 13 times h in this case was 25. Okay. So we're going to have that negative 13 times 25 would be a negative 325. Okay. So you want to be very, very careful with this and try not to make any mistakes. And you want to be able to do this all by hand as well. Okay. Like I said, you could multiply these equations out first, but you necessarily have to like box method that t minus 3 times t minus 3. And then you box method what you get from there with 4t minus 5. And then you can substitute in the negative 2. Don't do that. Substitute in first. Get your numerical values. And then multiply. Same skills for this, and this is what I want you guys to work on. Hint, hint, substitute the 5 into the equations, get your values for g, get your value for h, and then whatever you get after that, multiply those two, and that's it. So that's going to go ahead and conclude our our practice here for Unit 1. You will get a brand new video for Unit 2, Unit 3, Unit 4, and Unit 5, and they're all going to be very much pen to paper skills, guys. We want to avoid the calculator as most of our tests will be non-calculator. If at any point you have any questions, please let me know. I will be giving out answer keys at the end of the week, but please make sure that you complete these before then, as I will be grading them on the spot throughout the week. Have a great rest of the day, guys, and we'll get you all set for the Unit 2 review for the following day. Have a good one. Bye, everybody.